Do you dislike wasting your time steaming wrinkles out of your clothes? Stress no further, Steve is your solution. Steve only has one purpose: steam your clothes. Steve utilizes the KR4 with its exceptional capabilities to move freely, as it is a 6-degree of freedom robot. This model was downloaded and scaled within Blender to get the correct size to fit the DH parameters of the robot, which were created within MATLAB. It works in collaboration with the UR3, which picks up the selected item of clothing whilst Steve steams the clothing with its custom end effector. If we take a look at the environment, we can see several safety features that allow for the safest operation of Steve. This includes a control panel located at a safe distance from the robots, which controls the robots, as well as an e-stop to stop the robots at any point. There is also an included light curtain. Finally, there is a fire extinguisher in case of emergencies and a large e-stop on the floor near the robots in case the robots start to move. Through the use of MATLAB and the Robotics Toolbox by Peter Cork, this project became effortless due to the built-in functionalities of the toolbox. When developing Steve, an advanced user-friendly GUI was developed to ensure ease of operation. The GUI contains 3 tabs, which include features, robot jogging, and visual servoing. With safety at the core of this project, a simple 2-start system is implemented to ensure that Steve only starts when the user wants. First, the user will select Enable, which switches the text from Not Ready to Ready. After this point, the user can select Start and then select what feature they wish to demonstrate. Task Routine demonstrates the 2 robots working together to steam clothing. This demonstration of the robots utilizes icon to get joint states of the robot at a desired end effector location and uses JTroj to animate along that desired path to create smooth movements. Light Curtain demonstrates all movement of robots halting if the laser lights are broken. This is seen as the model crosses the curtain. Collision Detection showcases a forced collision and the robot halting before continuing the movement once the model is removed. The 2 last demos both utilize active collision detection as well as RMRC to create pathing. All demonstrations can be stopped by either a simulated press of the emergency stop button or a real hardware button. To continue the movements, the user needs to repress Enable then Start. Furthermore, through the use of the GUI, the user is able to see how the KR4 can use visual servoing to detect clothing to regulate distance when steaming. Finally, within the GUI, the user is able to manually control the robot through the use of sliders and by connecting to either robot with a controller to control them with confirmation text to allow the user to know which robot they are connected to. A possible extension is for the KR4 to utilize visual servoing to detect clothing to regulate distance when steaming. As for future applications of this, due to the advanced safety features and size of the 2 robots, they could be installed within homes. Rooms like a large walk-in closet or laundry room with the addition of a light curtain could utilize these 2 robots for added productivity. Additionally, Steve could work in collaboration with a humanoid robot that can retrieve the desired clothing item. Robots like this already exist within companies like Boston Dynamics, and research into this idea has already been conducted by David Estevez and his team. Link to research paper provided in the description. Thank you for watching our final video.